Now the definition is adsorbate. Adsorbate is your ink. So adsorbate definition is something which are going to be adsorbed. So adsorbate the substance which get adsorbed. The definition is the substance which get adsorbed. Adsorbent is your chalk. The substance on which on which adsorption takes place. Next definition is adsorption. So the phenomenon occurring here is called adsorption. Means adsorbate and adsorbent together gives you the term adsorption. Then we have to take another term. This is the desorption. It is actually removal of ink from chalk or removal of adsorbate from the surface of adsorbent. This is what is called your desorption. Next one is your sorption. So sometime both adsorption and absorption takes place simultaneously. This is what is called your sorption. So this point also remember that if the both absorption and adsorption takes place simultaneously, this one called sorption. In some cases, if you have ink are going to be adsorbed on the surface of the chalk, at the same time the solvent going to the bulk of the chalk. So from same thing we are going to be adsorption and absorption together. This is what is called sorption. Next point is your application of adsorption. So there are lots of applications of adsorption. This is application number 1 in medicine. In medicines, generally capsules are made of, the surface of the capsule is made of some adsorbent on which the microorganisms stuck and due to unable to do their metabolic activities, and thereby they die. Another one is that in order to create inert atmosphere, so if you spray something in our home which can trap the gases present in the atmosphere, so this can create inert atmosphere. Another one, the coal miners, the marks that they wear by coal miners, on that there is some adsorbent is there on their marks which adsorb the poisonous gases present there. Another one is that in order to control humidity, also if you spray something, that one can control humidity, can absorb the moisture present in the atmosphere. So in the next page, we are moving to the next page. Here we are doing mechanism of adsorption. So here there is theoretical point of view I am showing. If you consider these things are your some gaseous particles, having kinetic energy. Now the molecules in the surface, this is liquid. You take water here, the molecules in the surface, the force act on that, it is like that. So it feels a net downward pull, but molecules in the bulk, all the forces cancel out one another. There is no net force on the molecules in the bulk, but there is a force inward pull is there, and the particles, gaseous particles there, they will attract those gaseous particles. Now due to this, what happens, the kinetic energy that possessed by the gaseous particle, that one decreases, and energy, we know that energy cannot be created nor be destroyed, and this kinetic energy that is restricted there releases as heat energy. So what we can tell, that the adsorption is an exothermic process. Clear? So in absorption, if you consider the del G1, del G equal to del H minus T del S, so absorption takes place, del H become negative for exothermic process. So absorption is a spontaneous process will take place. Now we have to learn the one more thing. This is your adsorption, types of adsorption. There are two types of adsorption. One is your physisorption, another one is chemisorption, and their difference we have to learn. Just a minute. So we have to learn the difference between physisorption and chemisorption. Physical adsorption is what is called your physisorption, and if anything adsorbed chemically, this is chemisorption. In physisorption, give me some seconds. Sorry for the disturbance, student. Now adsorption are two types. One is physisorption, another one is chemisorption. So in physisorption, it takes place due to physical adsorption. For example, if you have a table, then if you have kept that one for 1 week or 2 weeks, so their layer of dust falls one after another into it. This is a physisorption, and easily you can wipe it out. But the chemisorption, if you give some color on the table, then that becomes stuck to the table. So this is called your physisorption. Now the chemisorption. In physisorption, the particles get adsorbed due to van der Waals force of attraction, and in chemisorption, particles get attached due to formation of chemical bond. In physisorption, there is multimolecular layer. Means one after another the layer is developed. In chemisorption, there is a unimolecular layer. So what is unimolecular means one chemical bond, if it is not broken, then another will not going to form. But the physisorption, you see, one layer after another can develop. It is not specific it is specific. So again, not specific means what? In phase option, since there is a van der Waals force, any particle can join, but in chemical bonding, the bond should be broken and link up between the, for example, ethene will take the hydrogen, ethene will not going to take the argon. So like that, it is specific, it is not specific. And here is low heat of adsorption, and there is high heat of adsorption. So since it is weak bond, low heat of adsorption, it is high heat of adsorption. So these are the some difference between your phase option and chemisoption. The next video we are taking another important point. This is your adsorption isotherm. So adsorption isotherm is a graph. Adsorption isotherm is a graph which gives the relation between the amount of gas adsorbed by the adsorbent with pressure at constant temperature. Means, you know, when you increase the pressure, the adsorption is going to be high. Now, if gaseous substance is there, if you increase the pressure, the amount of gas adsorbed will be going to be high at constant temperature. Now, that relation between the how much a substance are going to be adsorbed, that is given by your adsorption isotherm. It is a graph between amount of gas adsorbed on the unit mass of adsorbent x by m versus pressure. For example, this is your ink, and how much ink is adsorbed in a unit mass of chalk. This is called extent of adsorption. So how much adsorption takes place on the unit mass of chalk versus pressure is what is called adsorption isotherm. Isotherm means something we have drawn at constant temperature. Now, in this regard, we have drawn a graph that is on Freundlich adsorption isotherm. This is extent of adsorption versus P. Now, what is the graph is gives you that pressure increasing, at first your x by m is directly proportional to p to the power 1. Here it becomes constant, so x by m proportional to p to the power 0. So pressure has no effect. After some time, automatically adsorption stops. Here we have to concentrate. Here x by m varies to p to the power 1 by n. This is at moderate pressure, x by m varies to p to the power 1 by n. So we have written at moderate pressure x by m varies to p to the power 1 by n. So what I have told student, this x by m is also called extent of adsorption. Extent of adsorption. So let us know the terms, where x is the amount of substance adsorbed, m is the mass of the adsorbate, p is the pressure. Now if you calculate this one, student, x by m is equal to some constant k, p to the power 1 by n. This equation can be written like that. So which implies If I take log in both sides, log x by m equal to log k p to the power 1 by n, so that can be written as log k plus 1 by n log p. So this is what the equation comes. Log x by m equal log k plus 1 by n log p, or you can write that log x by m equal to 1 by n log p plus log k. So this equation become y equal to mx plus c. So y equal to mx plus c graph also we can draw. So if we draw that y equal to mx plus c graph, so for that this one become, the equation become y equal to mx plus c. The graph should be looks like that. So this is your log p and this is log x by m, and this one is your intercept log k, and slope will be your 1 by n. So that's all for today. Next day we'll start from this point.